Hey, you guys, good morning. Hope you're doing well. This is Thursday, and we're getting ready to work on 7-5. All right, let's get started. This is day 1 of 7-5, and tomorrow we'll do day 2. So today is Thursday, April the 23rd. All right, so look at the title. It says we're going to be doing exponential and logarithmic equations. We're just going to be doing the front of this lesson today, and then we'll do the back of it tomorrow. All right, an exponential equation is any equation that contains a variable that is in the exponent. All right, so for instance, if we had log base b of x equals y, if we took a logarithm and we changed it to exponential form, it would be b to the y equals x. Do you see that there's a variable in the exponent? Okay, so that's considered exponential. Okay, we turned a logarithmic equation into an exponential one. So an exponential equation has a variable in the exponent. All right, I'm going to walk through these steps. We're going to start with number 1, and what we're going to do is we're going to solve for x. Now to do that, we have to isolate the exponential expression. But if you look at every problem that I'm circling that has an exponent in it, they have actually already been isolated for you. So for these first 4 problems, we actually skip step 1 and we go directly to step 2. I'll show you how to do step 1 on the bottom of this page. You're going to rewrite 2 sides of the equation with the same base. All right, so we already see that the left side has a 3 in it. So we know that we can write 27 using base 3. So we're going to do 3 to the third equals 3 to the x minus 2. All right. Third step, set the exponents equal to each other. So I'm going to set 3 equal to x minus 2. All right. Fourth step, solve. So we're going to add 2 to both sides, and x is going to be 5. So that was really pretty simple. We took the exponents and we set them equal to each other and solved. We've done that before, so this should be pretty familiar. All right, let's look at the next one. Now, I know that this is an 8, but I also know that 8 to the 1 is 8 and 8 to the 2 is 64, so I cannot use 8 as my base. I'm going to have to use 2 as my base. So I'm going to write 16 as 2 to the 4th. Now, I still have to write as my exponent 3x because that hasn't changed. All right, now I'm going to write 8 using base 2. So that's going to be 2 to the 3rd. That's 8. So we rewrote the 2 sides of the equation with the same base. That was step 2. Remember, we're skipping step 1 for just these 4 right here. Step 3, set the exponents equal to each other. Okay, before you do that, you have to go ahead and multiply these 2. Okay, so this is 2 to the 12x equals 2 to the 3. Okay, now I can set the exponents equal to each other. I'm going to do 12x equals 3. So 12x equals 3. Fourth step, solve. So divide both sides by 12, and you're going to get x equals 1/4 because you want to make sure that you reduce it. All right, example C. Isolate the exponential expression. Done for you. Step 2, rewrite the 2 sides of the equation with the same base. Okay, this has a 2, and so I'm going to write the one on the left using 2 as the base. So we know that's 2 to the 4th, and then you still have to write this exponent because it is still part of the problem. You're just replacing the 16. All right, we're going to multiply the 4 times the 7. So it's going to be 2 to the x plus 5 equals 2 to the 28x. All right, the next step that we're going to do is we're going to set the exponents equal to each other. So I'm going to set x plus 5 equal to 28x. Subtract x from both sides, and you'll get 5 equals 27x. Divide both sides by 27, and you will get that x equals 5/27. All right, problem D. We don't do number 1 because the exponential expressions have already been isolated. So we're going to go straight to number 2 and rewrite the two sides of the equation. Now, this has a 9, but I know that 9 to the 1 and 9 to the 2, neither one is going to equal 27. So I'm going to have to change those bases to 3. So 9 can be changed to 3 squared. So I'll do 3 squared in parentheses and then put my 6x on the outside. It's still an exponent. My 27 is going to be 3 to the third. So I'm going to do 3 to the third in parentheses, but then I'm still going to put my x minus 2 as my exponent because that did not change. We're just replacing the bases. All right, next step is you're going to have to multiply. You're going to multiply 2 times 6, and then for this right here, you're going to have to distribute the 3. You cannot just multiply the 3 times the first term. You have to multiply it by both, so it's being distributed. All right, so 3 to the 12x equals 3 to the 3 times x is 3x. I'll move that parentheses just a little bit out of my way. And then 3 times negative 2 is negative 6. Okay, now we're to step 3 where it says set the exponents equal to each other. So we're going to do 12x equals 3x minus 6. We're setting these two equal to each other. All right, so now you're going to combine like terms. We're going to subtract 3x, and we're going to get 9x equals negative 6. And then we're going to divide both sides by 9, and we're going to get x equals negative 6/9. But let's go ahead and reduce it, and let's do negative 2/3. All right, so we had exponential equations, and we solved for x. All right, let's go to the second part of this lesson. And this part has to do with if the bases cannot be written with the same number. We're going to be kind of doing the same thing. So we're going to start off with step 1. Isolate the exponential expressions. Okay, I'm looking at this one, already isolated, already isolated, already isolated, already isolated. Whoop, not isolated. It has a 7 with it. Whoop, not isolated. It has the 8 with it. So I am just going to circle those two problems because those two problems are the only two problems on this front side where we're going to be doing this first step. But you have to check and see if it needs to be done. All right, so we're going to go ahead and start with A. We know that we don't have to do the first step, so let's move on to the second step. Second step is rewrite the equation in logarithmic form. All right, so we're going to do log, what's our base? Is 3. Log base 3 of what? Of 30 equals what? That's the exponent, x. Okay, so we rewrote it in logarithmic form. Now our third step is we're going to use the change of base formula to convert it to a common log because we want it to be a common log, which is a base 10. That means we can get a real number and we won't have the word log in our problem at all. So we're going to take log 30. It's in the numerator. You take log 3 because 3 is the base and it's always in the bottom basement. Okay, equals x. All right, now pick up your calculator. Turn it on, clear it out, whatever you have to do. Do log 30, but it's real important that you do this next step or you might get it wrong. Close that parenthesis. So when you're typing this in, it looks like this, log 30. And you literally have to close that parenthesis. All right? And then do the divide by button, divide by, and then just write in log 3. Type in log 3 and hit the equals button. So you just have to close off that parentheses. All right, so x is, and they want us to round it to the 10,000ths. So that means we're going to do it 4 decimal places. So you should have got 3.0959. All right, let's move on to B. All right, first step we know we're skipping because it's already been isolated. We're going to rewrite the equation in logarithmic form. So we're going to say log base B of 512 equals our exponent, which is 4x. All right, now we're going to do the next step, which is use the change of base formula to convert to a common log. So we're going to say log 512 divided by log 6 equals 4x. All right, now we have to solve for the variable, so I still have to get x by itself. So you're still going to do log 512 divided by log 6, but I want you to put that in parentheses, because what we're going to have to do now is we're going to have to do the opposite of multiplying. I'm going to have to divide both sides by that 4. So I'm going to put divide by 4 equals x. All right, so now this is how you're going to have to input this. Clear out your calculator. Log 512, close the parentheses, divided by log 6, hit the equals button. That is what log 512 over log 6 equals. Now divide that by 4 and round it to the nearest 10 thousandths. So x equals 0.8704. All right, C. Isolate the exponential expression. Check. Already done. Rewrite the equation in logarithmic form. All right, so we're going to do log base 2 of 12 equals 5x plus 6. All right, next step, we're going to rewrite log base 2 of 12 using change of base formula. So log 12 divided by log 2 equals 5x plus 6. All right, we're going to solve for the variable, which means we need to isolate the variable. So we're going to rewrite log 12 divided by log 2 and put it in parentheses. Now, let's look at our equation. The first thing we're going to have to do is subtract 6. So I'm going to subtract 6. Okay. I'm going to show you this in steps. Equals 5x. All right, now I still have to get the variable by itself. So I'm going to have to divide both sides by 5. So in order to do that, there's something I have to do. I have to take this whole piece and kind of set it off to the side together. So we're going to rewrite it. Log 12 divided by log 2 in parentheses minus 6 from it. We're going to put this in braces. We're going to divide by 5, and then we're going to get our x. So we have to do it in this order. All right, clear out your calculator. In order for us to find x, we're going to have to plug in this first. Log 12, close your parentheses, divided by log 2, hit the equal sign. That's what log 12 divided by log 2 is. It's approximately 3.58. Now, the next thing is subtract 6. Press the equals button. You get negative 2.4. Now, divide by 5. Press the equals button. You should get a negative number. You should get negative 4830. So for this one, it's really, really, really important that you do it in order. If you just plug the whole thing into your calculator, because a lot of calculators are set up using PEMDAS, please excuse my dear Aunt Sally or Susie, whoever she is, they will actually divide, it may actually divide this first, and you can't do that. You have to do it in the order that you did it here. Right here, you subtracted 6, and then you divided 5. So I always press the equal sign. After I do a log, I press the equal sign. I subtract 6, I press the equal sign. I divide by 5, and then I press the equal sign. Because I don't trust calculators, because some work using order of operations and some don't. And I don't know which calculator you're using, so I got to cover our bases. All right, let's go down to D. All right, first thing, isolate the exponential expression. Check, already done for me. Second step, rewrite the equation in logarithmic form. So we're going to do log 20. I'm sorry, let me do this first. Log base 11 of 25 equals x minus 1. All right, we're going to rewrite it. Log 25 using the change of base formula divided by log 11 equals x minus 1. All right, now we're going to have to add 1 to both sides. So when I rewrite my log 25 over log 11, I'm going to put it in parentheses, and then I'm going to add 1 to both sides. So I'm going to put plus 1 equals x. So in order to find our x, we're going to plug it into our calculator this way. All right, hit the clear button. Log 25, close your parentheses, divided by log 11, press your equal sign. You should have got 1.3. Add 1 to it. You should have got 2.3, and we're going to round it 4 decimal places. So 2.3424. All right, let's move on to E. Now, you notice I circled E. Remember, we said that we're going to have to do the first step. Isolate the exponential expression. This 4 to the x is not by itself, so I have to get it by itself. So I am going to subtract 7 from both sides. All right, so I'm going to have 4 to the x equals 64. Now, step 2, rewrite the equation in logarithmic form. So, log base 4 of 64 equals x. Now, use the change of base formula to convert the log. All right, log 64 over log 4 equals x. Okay, this is a simple one where we just plug. All right, so clear your calculator, type in log 64, close your parentheses, divided by log 4 equals, now I just got 3 and you should have 2. We don't have to write 0.0000. That's not necessary. All right, last one. All right, now you see we're going to have to do that first step where it says isolate the exponential expression, and we're going to have 2 steps this time. All right, the first thing we're going to do is we're going to subtract 8 from both sides. So let's do that first. So I have negative 2 to the x equals negative 75. Now you see that negative out in front of the 2. We've got to get rid of that. So we're going to multiply everything by negative 1. All right, when we do that, we basically just get rid of the negatives because there was a negative on both sides. So we have 2 to the x equals 75. All right, now use the change of base formula to convert it to a common log. So we're going to do, well, I'm sorry, I didn't rewrite the equation in logarithmic form. I have to do that first. So we're going to do log base 2 of 75 equals x. Now we're going to use the change of base formula. Log 75 over log 2 equals x. All right, we're going to plug that into our calculator, so clear it out. Log 75, close parentheses, divided by log 2, press the equals button, round it to 4 decimal places. It'll be 6.2288. All right, that concludes today's lesson. So you kind of were doing the same thing on the top and the bottom, and you kind of were really using the same steps. The only difference is at the top, you isolated the exponential expression, you rewrote the 2 sides of the equation with the same base, and you set the exponents equal to each other, and then you solved. It was somewhat similar. For this one, you isolated the exponential expression just like you did above. But instead of rewriting the 2 sides of the equation with the same base, what we did here is we rewrote the equation in logarithmic form. Log base 3 of 30 equals x. Then we used the change of base formula. We didn't use that up top to convert it to a common law, and then we solved for the variable. All right, let me write your homework for tonight in case that's helping you. Me writing it down here so you don't have to go look it up. All right, this is Exponential Equations, Section 7.4, Day 1, page 481 to 483. You're going to do 11 through 27 odds and problems 67 and 75. All right, 11 through 27 odds and problems 67 through 75. All right, you guys, you have a good Thursday, and I'll see you tomorrow, all right? Bye.